Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you who are participants and students for this course titled Multi-Criteria Decision Making under MOOC NPTEL series. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. And if you do remember, we have covered the few examples in details about the analysis. We have covered the concept of utility theory, many different descriptions about the ideas of what is utility function, the concepts and the properties of utility theory, the ideas about different utility functions in general, like the quadratic, logarithmic, then the power function, exponential function, then these ideas and concept of absolute risk aversion, relative risk aversion, certainty equivalent. Then we considered the different other methods of trying to analyze decisions like geometric mean method, safety first principle, the three different concepts of safety first principle, how they can be analyzed pictorially. We also considered the concept of stochastic dominance. There are other different parts, but generally what we have covered as required. The discussion which we are going to have is basically we are going to start the 21st lecture under the NPTEL MOOC series for this multi-criteria decision making course, which is for 60 lectures. And the overall coverage is overall umbrella coverage which we will be doing through different lectures would be about MCDM, multi objective decision making, multi attribute decision making and multi attribute utility theory. What would be the coverage specific for this lecture? Obviously, there are many points written, and as you know, they will be kept updating. I will be keep updating them and putting there exactly what we are going to cover each lecture wise. And depending on that, and after listening to the videos and the overall inside discussion we will have about different topics and going through the slides, and obviously the textbooks which I mentioned are quite vast in number. After you going through that, you can do definitely each week there would be assignments, and after each week assignments, obviously you take the final examinations. So, the coverage here I am reading many of them, some would be discussed later on, would be MCDM, ideas and concepts, multi attribute decision making, multi objective decision making, multi attribute utility theory, MADM versus MODM, which is multi attribute decision making versus multi objective decision making, where MADM is more qualitative in nature, MODM is more quantitative in nature, and there are other differences also. We will consider Pareto optimality, property of dominance, strong Pareto optimality, weak Pareto optimality, and further on go into concepts of Pareto optimality in two dimensional space, effects versus inefficient solutions, Karush-Kuntakar condition, then scales of measurements, nominal scale, ordinal scale, interval scale, ratio scale with examples, and then go into goal programming. The ideas of multi-criteria decision making, which is a broader umbrella MCDM, whose aim is to facilitate the decision maker who is faced with numerous and conflicting alternatives and choices. When we mean by alternative choices, we have mentioned that I will always try to highlight the concept of alternatives and choices by using the set A, which I am marking. So, this bold A means a set, and there are different type of alternatives which we will denote by A from starting from 1 to M, capital M, and each would be based, each of these alternatives would be based on set of criteria or characteristics. So, buying a car, the car we would have a red color, mileage, but then the safety features, then the maintenance cost, all these would be characteristics or the criteria, and the car which would basically, or the set of cars which we will consider as alternative would be, say for example, can be Volkswagen, can be Kia Motors, can be Maruti Suzuki, can be Tata Motors, can be Honda, Hyundai, whatever it is. So, based on this criteria you make a decision for the alternatives. Buying a house, so what is the price of the house, if you consider the one of the examples we have considered in the first set of classes, like what are the safety features of the house, what is the carpet space, whether the schools are nearby, the hospitals are nearby, whether it is a gated community, or whether how far is the metro. So, those are the criteria, and the houses you can consider, like Mr. Murthy had considered different localities in Vizag. So, those are the alternatives which you have. If you want to go for higher studies, so if it is, say for example, higher studies in India, consider NITs, IITs. If somebody is interested to go for the engineering studies, somebody wants to go for the management studies, or somebody wants to go to social sciences, there are very good universities there. So, those universities would be the alternatives, and the alternatives would be based on criteria, maybe type of subjects which are taught, what are the job opportunities, what is the quality of faculty members, how far it is from the home, what is the hostel facilities, how is the library. So, those would be the criteria, and this criteria will denote by C, again bold C, and C is from 1 to n, and based on this set of criteria, as I said, you will choose the alternative. This is one decision maker who is choosing. In order to arrive at the decision, that what is the final goal, the decision maker is required, number 1, to identify the problem. What is the problem? What does he or she want to do? Is it to choose a house? Is it to buy the best house? Is it to choose buy the most safe, like if you want to buy a car, is the car based on the fact that it consumes the least amount of fuel? Then based on that, he or she constructs the set of preferences. Preferences are basically what are the different type of choices which are there for him or her. He or she then evaluates the alternatives, evaluates the choices, and based on the criteria, based on the ranking of the criteria, he or she basically determines the best alternative and the choices and ranks them. For the later two steps, which is basically choosing and ranking, 3 kind of formal analysis are there, and those are descriptive in nature, prescriptive in nature, and normative in nature. The descriptive analysis basically also is termed as the behavioral decision research and is qualitative in nature, while prescriptive and normative are more quantitative in nature. So, we will try to analyze both of these type of problems, where quantitative techniques as well as qualitative techniques would be utilized to make a decision of the alternatives based on the different type of criteria which is there for each alternative. The relevant questions pertinent in MCDM, MCDM again I am saying is the broader umbrella, which need to be answered are: what are the preference structure based on the decision maker's choices, what are the weights he or she is going to give, like relative weights, relative importance which the decision maker will assign, and if there are conflicts among the different type of criterias and characteristics, how they would be solved by the decision maker. Conflict can be safety features is very good, which I like, but price is very high, which I want to avoid. I want to go for a lower priced or lower budget car. Or else consider the flat is in excellent location, which has got very good hospitals nearby, it is safe, good transportation nearby, but the flat size is very small as per my requirement. Or consider that I want to go to one of the IITs or IIMs or one of the best universities, maybe Delhi, Bombay, Madras, Calcutta, whichever university, to study for higher studies. For IITs it can be engineering related based studies, IIMs and other schools would be for MBA related, those universities may be for social sciences, basic sciences, whatever it is. So, consider the person wants to go to, say for example, Calcutta University, but it may be too far from home, or there is a lack of accommodation, or say for example, Delhi University is the first choice of the person to go for higher studies, masters, but maybe it is difficult to get admissions there considering the cutoff. So, those different ways of trying to analyze the alternatives based on the conflicting one, and weights would be assigned. Conflicting concepts are the examples which I gave. Weights may be, consider for me, if I consider a college, for me the level of courses and the level of faculty members and the rigor of the courses would be more important than trying to understand what is the job features, what is the internship, what is basically the final placement. For some other person, it may be just the other way around. For him or her, job facilities, internship facilities, then long term employment would be much more important than the rigor of the course. So, the weights would be assigned accordingly. MCDM may be classified into two main categories, which is, as I said, MCDM is basically the broader umbrella, the superset, under which you have the multiple attribute decision making. Attributes means characteristic based, which has limited number of predetermined alternatives and choices, or the criteria and characteristics, that there is a discrete decision space from which the person has to choose, with preference ratings being discrete, and one uses discrete mathematics to solve such problems. So, discrete set, so they are may be easy to solve, but trying to analyze the output may be difficult. While the second set, which is multi objective decision making, which is much vaster in this application, is based on concept of mathematical programming and is applied on a continuous solution space and consists of set of quantifiable objectives. They are well defined and there are well defined constraints, as the main concept considers a huge variety of interactions within the given constraints to arrive at the final decision under the concept of MODM. So, MODM may be quite big, maybe there are different type of mathematical models, but they are easy to analyze in the sense trying to basically bifurcate which is good, which is bad, which should be the top priority, which should be the bottom priority, is much easier to do than with respect to the concept which are under multiple attribute decision making. Thus, it is easier to arrive at the best solution using the sophisticated mathematical programming techniques, which is under the purview of multi objective decision making. Multi attribute decision making, or MADM, as I was discussing, the first subset under MCDM, can also be given the name of multi attribute utility theory. So, there are multiple attributes or characteristics based on which the utility theory or the preferences is analyzed. And also under that you have the outranking method, which will be one main part of our discussion. MAUT, which is multi attribute utility theory, represents the problem as an hierarchy structure utilizing different concepts of utility theory, where the decision maker chooses the best alternative based on the highest utility value or the net value or the value which is good for him or her, the decision maker. While on the other hand, the outranking method, which basically utilizes the relationship of outranking, how is one alternative better than the other, what are the good features of the alternative than the other. So, basically one wants to outrank and make the decisions accordingly. Utilizes the relationship of outranking to order the alternatives and the choices on a functional relationship, where the functional relationships are basically denoted by this, which I am highlighting. So, when you are considering two alternatives A I1 and A I2, where I1 and I2 are all elements of M. M is basically the number of alternatives which you have, and J is the characteristics, which is J is equal to 1 to N. So, you will basically for each criteria you will try to basically compare the alternatives and basically make a ranking such that in case AI1 is better than AI2, we will say that AI1, which is alternative AI1, would outrank the other alternative AI2 based on the characteristics, based on the criteria. Maybe for the second set of criteria the ranking may change. So, what you do is basically you consider each criteria, compare the alternatives and basically rank them. Then move to the second criteria, again compare them. In doing so, you will basically have a set of ranking based on the criteria for all alternatives and then combine them accordingly. Now, there is one important thing which should be remembered, that when you are going to compare the alternatives based on any one particular criteria, you are very simplistically considering, which may not be true in actual practical purposes, that you are very simply considering that the alternatives or the characteristics are independent of each other, which may not be true. So, that may be one of the important points, or which can be considered an important lacuna considering the different types of multi criteria decision making, multi attribute decision making we will be basically considering. In multi objective decision making, which is the second subtopic under the multi criteria decision making, a decision maker again, as I said, faces a list of characteristics on criteria, which we have already denoted by C1 to Cn, n is in capital, based on which he or she wants to choose from a set of alternatives A1 to Am, I is equal to 1 to m, which may have conflicting outcomes. Mathematically, MODM, which is multi objective decision making, can be written as follows. So, you have different multi objectives. So, the first multi objective or the objective is F1. Next, you will basically have, which is not written here, you will basically have F2. I am not writing x, I am just denoting the functions as f, the suffix. Then you will basically have the third objective function F3, so on and so forth till you have the capital N. So, this capital N should not be confused with the n which is there for the criteria. So, actually when you are trying to solve the problem, the number of characteristics and the number of optimizing objectives may be different. So, the n which is shown in criteria and the n which is shown in the objective function f1 to fn are different. Now, you want to optimize these different type of objective functions collectively, multi objective, based on some criteria, and the such then constraints are given as gk, which is any constraint, is less than equal to bk and k is equal to 1 to capital K. Again k, this k, m, n are different, and x we will consider is always on the real line, and there are basically L is of a dimension L. So, again do not confuse this L with n, which is the number of objective function. Here x, which is the vector, x1 to xl is the vector of decision variables, total Ln number which I mentioned. M is the number of objective functions, each being denoted by f1 to fm. So, this actually is n, and k denotes the number of constraints of the form given as gk, x is less than equal to bk and k is equal to 1 to k, and we will consider these problems accordingly. Now, one may solve these type of problems in variety of ways. So, one of the simple way to solve this problem would be, why not consider them individually as single objective function, and once you solve the single objective functions, you know what is actually the maxima or the minima for each of these objectives. So, then what you do is that you put the first objective as in level 2, you put the first objective to be optimized and consider the other objectives are based on the constraints such that the boundary of the constraints are taken as the objective values which you based on which the second objective, the third objective, the fourth objectives were basically considered. We will see that later. Then in the same step, which is case 2, you basically solve the objective function as the second one, but now considering objective 1, objective 3 and so on and so forth as the constraints. So, simply we first, again I am repeating, we first consider single objective for all these objectives, solve them, and in the next step considering the objective functions one by one, but now considering the other objectives which were left out are part of the constraints accordingly, and then we solve it. So, this is one method, but there are problems here which we will discuss. The second way of trying to solve the problem is that we give some weightages and weightages on the objective function such that we will combine this objective function all separately, multiply individually by the weights, and there are some restrictions in the weights, and then basically solve the problem as a single objective function such that the weights can be changed in order to find out what is the important level importance we are going to give for each and every objectives accordingly. There are other methods also. So, first we will start with these two methods and solve and proceed accordingly. One may solve the optimization problem first by formulating in two different ways which I mentioned. One is optimize fi means any objective function you optimize, but what you do is that you consider the constraints as they are. So, gkx is less than equal to bk remains as it is, but interestingly all the other objectives which you have, which I will denote now. So, consider the same problem, consider here f1 to consider f4, right. So, what you do is that you basically and consider you want to optimize, I will use the word optimize, it can be maximum, minimum, whatever it is, such then conditions are I will consider g1, I am not writing x, g1 is less than equal to b1, and the second constraint is g2 is less than equal to b2. So, what I will do is that I will use a different color in order to explain that. So, consider the blue one. I will solve f1 first, and what are the constraints? The constraint of g1 being less than equal to b1 remains, g2 being less than equal to b2 remains, and I will put some of these other objective functions which are f2, f3, f4 and bring them into the constraint. So, I will write down as I am using different color, I will put f3 as now this f3 is a part and parcel of the constraint is greater than equal to or less than equal to, even though I have written greater than equal to, that depending on optimization whether is maximum minima, or I can use less than equal to, say for example a3, and this a3 has to be decided. This is what I said that this can be a little bit tedious work. The second, the other objective being added again greater than equal to less than equal to would be a4, again a4 has to be found out such that this is met, and another one which I have missed is basically f2 greater than equal to less than equal to a2. So, now the first and so I am trying to optimize f1. So, I will basically I have converted this multi objective into a single objective and considered the constraints and added the constraints of this the objective functions which have been left out and solve it. Now, the question would be if this is basically for objective function 1, can we formulate a similar set of problems based on only objective function 2? The answer is yes. So, again I will use a different color now green one. So, now you will have objective optimize f2. Now, we are only considering f2, nothing of the other. So, subject to constraints g1, g2 remains. So, they will be copied, and now f1, f3 and f4 will come as part and parcel of the constraint. So, f1 less than equal to greater than equal to some a1, f2 is already there in the objective function. So, it would not be considered. So, this is f3 greater less than a3, and the last constraint to be there is f4 greater less than a4. Now, This would be, I would name it as 2. In step 2, this is the second model you will solve. In step 1, this blue one, in step 2 also, this is the first model you will solve, and if I consider the F3 and F4, the corresponding part would be, I will erase one by one and write it. So, it is easier for us. So, I will erase the blue one, which was for F1, and use a different color. Let me use the color red. So, you will have optimize F3 now, because F1 already considered, F2 already considered. Constraint G1 remains as it is, G2 remains as it is. Now, F1 is not there in objective, so it will come. So, it will be greater than equal to, less than equal to A1. A1 has exactly in somewhere. A1 is basically a constraint I want to put for the value. F2 is not there in objective function, so it will be considered. F3 is not being considered, so it will be removed, not be considered here, only F4 will come. So, this would be so called problem 3 or a sub part for the step 2. Finally, I know I am going a little bit slow, but please bear with me. If I consider F4, so you will optimize F4 subject to G1 less than equal to B1, same thing is being copied, G2 less than equal to B2, then F1 is not there. So, F1 would be greater than less than equal to A1, F2 is not there in the objective function. So, it is obviously greater than equal to less than A2. I will write F3 here, because F3 is not there in objective function, is greater than equal to less than equal to A3, but F4 is already considered. So, this would basically formulate the sub part 4 of second step. So, this is what is written here, I will read it. So, if I consider the first method which we are discussing, so I will erase all these things and not make it cluttered. So, this was optimize based on the fact that you will individually consider, and obviously there is a other way of the second method is also there, which we will discuss. So, here AS are the predetermined respective thresholds for the Sth objective function which I mentioned, and based on that we will solve the problems. Then we will consider, first we will consider the other concept which I am putting a tick mark here in the next lecture, and continue discussing very simple ways of trying to solve multi objective problem formulation. Have a nice day and thank you very much.